Welcome to clickmyproject.com. Now I am going to discuss about the supervised spatio-temporal neighborhood topology learning for action recognition. Now I am going to describe the brief introduction about this process. Supervised manifold learning has been successfully applied to the action recognition process. However, the land manifold may not be able to well preserve both the local structure and the global constraint of temporal labels in action sequences. To overcome this problem, this paper proposes a new technique, that is algorithm, namely supervised spatio-temporal neighborhood topology learning for action recognition. We propose to construct the neighborhood topology using both supervised spatial and temporal pose corresponds information. Experimental results demonstrate that SSTNTL outperformance the manifold embedding methods with other topologies or local discriminant informations. First we load the input video. In this folder we collect the videos. Then the next process is the frame conversion, that is in pre-processing we converting a video as frames. A film frame or video frame is one of the many still or nearly so images which compose the complete moving picture. Individual frames are separated by frame lines. Normally 24 frames are needed for 1 second of film. In ordinary filming, the frames are photographed automatically and one after the other in a movie camera. In special effects or animation filming, the frames are often shot one at a time. Then the next one is the foreground separation, that is background subtraction. In this module, we separate the foreground and background from the frames. A common assumption for background subtraction is that certain attributes of the objects of interest change more rapidly than the background scene. The simplest methods of background subtraction keep a running mean or median of previous frames as a model for the background. While this is efficient and simple to implement, we convert the frames as a binary image. It contains only as zeros and ones value. Then the next step is the temporal pose corresponds. In this, the one of the method are to extract the feature like a pose information of the action. Initially we deduct the pose person from the image and we plot the rectangle to the corresponding place. After identifying the person, the information of the pose such as center, width, height, mean value are identified. The identified information is stored for further process. Then the next one is the spatio-temporal feature extraction. Spatio-temporal feature extraction is one of the feature extraction method. Here we extract the feature of the video by spatio-temporal algorithm. First we select the candidate points based on self-deductor. Next we calculate the several motion features at each point with local temporal units divided in order to consider consecutiveness of motions. We calculate the variations between the each frames. This value will be used as a feature value of video. ST means that is spatio-temporal feature is based on the speed up robust features and then optical flows deducted by the Lucas-Cannon method. For designing a new ST feature, we set the premise that we combine it with holistic appearance features and motion features by multiple kernel learning. Therefore, the important thinking is that it has different characteristics from two kinds of holistic features. Then the next one is the action classification. In action classification, we use KNN classifier to predict the result about the action. KNN is a non-parametric method for classifying objects based on closest training examples in the feature space. An object is classified by a majority vote of its neighbors, with the object being assigned to the class most common amongst its nearest neighbor. K is a positive integer, typically small. If K equal to 1, then the object is simply assigned to the class of that single nearest neighbor. Now I am going to explain the implementation of the supervised spatio-temporal neighborhood topology learning for action recognition. This is the MATLAB command window. These are the files used for this process. Main is the main function file and the others are the subfunction files. Choose the main and click the option choose run file option. This is the guide window designed for supervised spatio-temporal neighborhood topology learning for action recognition. First, load the video. Choose any one of the video from the dataset. So the video is now I am choosing the jump video. So the jump video is displayed in the first axis. The next process is converting the video into frames. In this we convert the jumping video into 50 frames. Then next is the foreground subtraction. Next one is the temporal features. In temporal features, just note the person only and extract the features. Then the next feature extraction method is spatio-temporal feature method. So the spatio-temporal features values are extracted and displayed in the second table. So the process is going on. The feature extraction values are over. Then the next method is the classification. Here KNN classifier used. So now we use the KNN classifier and classify what is the action recognition done. So we give the input video as jump and action recognized also jump. Then the next one is that we find the accuracy for the classification process. We get 97.83 accuracy in our process. Generalized eigenvalue function problem to obtain the best projection, and that not only separating the data points from the different classes. Thank you.